here's a problem about lenses. So of course this one requires a diagram, big time. So let's see if we can get a diagram going here. Diagram will start like this. Here is the axis of the lens. See how straight that is? Amazing, isn't it? Okay, now the lens is somewhere on this axis. We'll put it right here, like this. There's the lens. And it says this lens has a focal length of 22 centimeters. So we're going to very cleverly say 22 centimeters is right here, like so. And so the focal length is on both sides. This also is 22 centimeters. These are the focal lengths of this lens. Now it says there's an object placed 30 centimeters from this converging lens. So if that's 22 centimeters, then we're going to put an object at 30 centimeters. So that will look like this. Object. Look like an object? I hope so. So it says draw a ray diagram approximately to scale. Oh, that's part B. Can we do B first? Okay. So to draw a ray diagram, what we have to do is we draw the diagram, we draw the ray as the first part of our diagram that goes directly parallel to the axis until it gets right to the lens. Then it gets refracted at the lens. And what it does is it goes right through the focal length. So then it does this. So that ray of light from the top is then doing this kind of a business. Looks like so. There's another ray. This other ray goes right through the center of the lens and is undeflected. So that ray looks like this. So it continues that way. Okay, so there's a couple of rays. Pretty straight? Not too bad. You can do better because you have the capability of using a straight edge. Okay, so there they are, and it says that, what would you see if you, the observer, is over here like this, at your eyeball, looking at this, what is it you're going to see? You're going to see light emanating from this point. There's light coming out of here. So as far as you're concerned, there is something there. And that's the tip of this object. So as far as you're concerned, that's what you're going to see. Now we have a little bit of a problem here in the sense that it says find the image's position. Well, we can't find the image's position directly from the diagram, maybe unless we drew the diagram really accurately. But as it is, we can say that this distance here is d of the object, dO. This distance here is the distance of the image, di. The focal length is this thing that's called f. So there's the focal length. The really nice equation that describes all this that you'll find from your physics book is the one that says 1 over dO plus 1 over di equals 1 over f. So when you solve that, then what you're going to find is that di is the same thing as 1 over f minus 1 over dO, all to the minus 1 power. And when you put in the right numbers, you find out that the answer to this is that the image distance is 82.5 centimeters. So if we could measure this, we'd have 82.5 centimeters. So then, does that seem right? We're looking at this object, and it's farther away than the focal length, and the image we see is upside down, so it's inverted. Okay, seems to make sense. Good.